Okay, so now we're going to go ahead and we're going to talk about some more tests on proportion, significance tests, but now we're going to look specifically at the two-sided test. So if you really don't know if it's going to be greater than or less than, you could say that it's not equal to. And so that's our two-sided test. I just suspect that it's really not equal to that PO, so I'm going to go ahead and move on. And I'm going to test that. So according to the Centers for Disease Control and Prevention, the CDC website, 50% of high school students have never smoked a cigarette. Taya wonders whether this national result holds true in her large urban high school. For her stats class, Taya takes a SRS of 150 students from her school. She gets responses from all 150 students, and 90 say that they have never smoked a cigarette. What should Taya conclude? Give appropriate evidence to support your answer. Sorry about the typo. So test the hypothesis that the true proportion of students that never smoked a cigarette is 0.5. So we go with that national average at a 0.05 significance level. So no difference. So P is 0.5, but we think that there's a difference. So but we're not sure if it's higher or lower. So we're going to say P is not 0.5. And then so this is what we usually do. We kind of say, oh, I'm not sure if it's higher or lower. So here's my null, here's my alternative. Then we grab the sample. Because the sample will kind of tell us, is it higher or is it lower? But we can't do the sample first. We have to state our values first, or else we're cheating, and it's just really bad science. So where P is the true proportion of students that never smoked a cigarette. Okay, so if conditions are met, we will perform a one sample z-test for proportions. So random, we had a simple random sample of 150 people. We're going to test that half of them is at least greater than 10. Which is good because that's 75. So 75 is greater than or equal to 10. But we've got chest failures, which is the exact same. But we still have to check it because we have to be thorough to show that we know what we're doing. Independent, let's see, it's a large urban high school, so reasonable to assume there's more than 1,500. At a large urban high school. Spend half my time just writing the problem rather than saying it. Okay, so now we're going to move on. We're going to go ahead and find our p-hat. So for our sample, we had 90 out of 150, which is actually 0.6. So that's going to allow us to calculate our z, which is 0.6 minus our 0.5, all over the standard deviation of that. So 0.5 times 0.5 divided by our sample size, 150. So this gives us 0.1 divided by that standard deviation, 0.0408, which gives us a z-value that's positive, 2.4495. So now we have to calculate our probability. So now our p-value, we want the probability that z is greater than 2.4495, or, and we use this because this is what we got from our sample as a statistic, but because we were we weren't sure whether to go high or low, we actually have to also test that our, not P, that our Z value would be less than negative 2.4495. Because with the two-sided test, we have to check both sides. And so how does this end up calculating? Well, I'm just going to do a 2 times my, because remember this is a standard normal distribution, the area on this side should be the exact same as the area on this side in a standard normal. So I'm going to do a 2 normal CDF, where my lower bound is going to be the 2.4495. My upper bound is going to be 10. The mean is 0, and the standard deviation is 1 on that standard normal curve. And that's going to give us a, let's see, normal CDF, 2.4495. And then I times by 2. So now we have a 0.0143. And in fact, if I wanted to, I could double check my results by going into stats tests, 1 prop Z test, where our value is 0.5. Our sample is 90 out of 150. And we did a not equal to, and we can calculate. And we get a Z value, yep, and everything matches perfectly, so that shows that we did it right. And now we compare, is this less than our 0.05 value? And it is less than, so we reject our null hypothesis since our p-value is less than 0.05. We reject the null, which means that there is convincing evidence to conclude that the students that have never smoked a cigarette is not 0.5. The proportion, the proportion. So the proportion of students that have never smoked a cigarette is not 0.5, because that's what our alternative hypothesis was stating. Okay, confidence intervals and significance tests. So this is a connection between last chapter and this chapter. There is an actual connection between confidence intervals and significance tests. Significance tests can tell us if the smaller specific population proportion differs from an entire population proportion, whereas confidence intervals give us an idea of what the actual proportion may be. So it actually kind of gives us more data, because it kind of gives us a range of where the data may be. Therefore, a confidence interval can be more informative. Taya found that 90 of her random sample of 150 students said they had never smoked a cigarette. We checked the conditions before performing the significance test earlier. Before we construct a confidence interval for the population proportion, we need to check the normal condition again, because this normal condition uses our sample size. So with our sample size, we're looking at 90 and 60 for success and failure. That means that now we've met that, and we can continue with our calculations for a confidence interval. So now we're going to calculate a 95% confidence interval for the true proportion of students at the school that never smoked a cigarette. That have never smoked a cigarette. And we're going to do this with 95% confidence. So we're going to use a one sample Z interval for proportions. We checked the conditions. So we're going to go ahead and do a Z star for, inverse norm. And if it's a 95%, our area will be half of that, so 0.025. with a mean of 0 and standard deviation of 1. And I'm pretty sure that's 1.96. Yep, we use this one a lot. So our interval should be, okay, let's see. Our p hat was 0.6. We're going to plus or minus the 1.96 times the standard deviation, square root of 0.6 times 0.4 divided by 150. And so I get, let's see, 0.6 times 0.4 divided by 150, and then I square root it, and I times by 1.96. So I get a 0.6 plus or minus a 0.0784. So 0.6 minus gives me a lower bound of 0.5216, and then 0.6 plus 0.0784 gives me an upper bound of 0.6784. So instead of just telling me in my loss significance test that it's not 0.5, this gives me an actual range. So we are 95% confident that the interval from 0.52 to 0.67 or 68 captures the true proportion of high school students that have never smoked a cigarette. So it gives us more information than our significance test. But our significance test allows us to test a theory or an idea. So they each have their own purposes. What's really nice is there's a connection between the confidence interval and the two-sided significance test. So what we're going to find is they're totally going to agree with each other. The confidence interval gives an approximate range of values PO that would not be rejected by a two-sided test at the 1 minus confidence level. So if I'm looking at a 95% confidence level, I'm going to get a range of values that will not be rejected at a 0.05 alpha level or significance level on a two-sided test. But again, it's a two-sided test. Now, keep in mind that these are not perfect relationships, because as we look back at how we calculate our standard deviation here versus calculating our standard deviation here, there are some slight differences, because again, this is looking at the sampling distribution based on our original value, our original no difference conclusion, our national data. This was looking at the sampling distribution based on our sample data. And so again, our sample data may be way off, so it could throw things off. So it's not perfect, but it's really, really close. So our test statistic and our confidence interval really, really closely related. And so on the AP exam, it's acceptable to use a confidence interval instead of a two-sided significant test, because it's going to give you more information, which is really nice. But if it's a one-sided alternative hypothesis or a one-sided significance test, then you can't substitute in a confidence interval. It doesn't work like that. So that's it for 9.2, and then we're going to start working on means.